delighted to be hosting today's session as we look at the EV market outlook trends and we explore the impact of electric vehicles on consumer behaviours, the governance landscape, and the game-changing benefits and applications of single-board computing, everything from efficiency, reliability, and cost effectiveness. A little bit of housekeeping for this session. We will be doing a Q&A after each segment, so please feel free to put your questions into the chat box. And this session obviously will be recorded, so we can share it after. So I just want to make sure everybody is aware of that. I am incredibly excited to be joined by a panel of guest speakers today. Please let me welcome and introduce Naeem Farooqi, the founder and CEO at Fleet Zero. And over the past 6 years, Naeem has been instrumental in providing trusted advice and solutions for companies' fleets in their transition journey towards zero emissions. Along the way, Naeem has been awarded significant accolade, including the top 40 under 40 from Transit, Excellence in Supply Chain Awards, and more recently, the Clean 50 Emerging Leader Award for the work that Naeem has been doing in the decarbonisation of transport. It's wonderful to have you with us today, Naeem. I'd also like to extend a warm welcome to Marc Palmer. Marc is the brand director at Autotrader and has extensive background in the automotive field, having worked for leading brands such as Nissan, Hyundai, Mercedes, and Ford. And now Marc leads the data and insight work for Autotrader's manufacturing agency customers, where he turns billions of data points and market research into simple stories and key themes, which I'm sure we'll hear some of that today. Before I hand over to Naeem, I just want to take a couple of minutes just to share with you who we are as OKdo. OKdo is a fairly new business. We launched in 2019, just ahead of the pandemic, but we have grown to be a successful global technology business working with some of the world's biggest technology companies. And you can see a few of them on this slide here. And what we offer to our customers is that we absolutely provide off-the-shelf hardware solutions to customers around the world, particularly in the space of industrial IoT, digital signage, and moreover, the EV charging wave that we are seeing globally. And we offer, alongside those products and technologies, the ability to provide design services for our customers, anything from customizing one of our products off the shelf to designing completely new applications. We offer global manufacturing services, so we can support customers from prototyping all the way through the scaling journey as they go to market. We're obviously a distributor. We sit proudly as part of the RS Group, a FTSE 100 company that provides electronic solutions to customers around the world. And we support all of that with our global community of almost 1.2 million engineers on the Design Spark community that help provide content, troubleshooting, and innovation to the customers that we work with. So it's really nice that we could put this session together today, along with Marc and Naeem. And we're also lucky to have some of the OKdo technology team with us to help support any questions that you may have that want to cover deep software or technical aspects. So a big thank you to Nils Christian, who's joining us from Sweden, Ule Valur, who's joining us from Denmark, and Raoul, who's joining us from Scotland. So with that, I'd like to hand over to Naeem, who's going to walk us through the EV outlook, adoption, and trends that we're seeing today. Thanks, Naeem.
Richard, thank you for having me here today. I'm looking forward to presenting about the EV outlook. So if we can get my slide deck up. Perfect. Next slide. So in terms of Fleet Zero, we always like doing a safety moment. So one of the safety moments I wanted to discuss briefly was around EV home fires, around EV chargers. EV chargers are, wrapped in high voltage with high voltage cords. Those cords that we've seen many incidences where people are treating them like garden hoses and they're driving over them and they're nicking and knacking them, and that's creating uh, sparks or creating exposed copper wire, and that is a safety risk. Today in North America, the number one reason for home fires is dryer vent lint, and they're predicting that in the next decade it's going to shift to electric EV chargers. So it's really important to be aware of proper use and storage of these charging cords. So please, whenever you're using your charger, make sure you physically check the wire that there has been no incident of damage. And when you're done using it, please put it away properly. It's not a garden hose. So next slide. So just briefly about Fleet Zero, we're a startup that's been around for about 6 months. We have offices in Toronto, London, New York. What we do is we leverage a global network of SMEs with a network right now of 24 individuals. And our disciplines are electrical, environmental, finance, mechanics, asset advisory, and engineers. And over my career, as well as some of our colleagues at Fleet Zero, we've done about 80 plus studies and about 22,000 fleet assets advised on globally. Next slide. So if I was a mechanic today going to school, I wouldn't know what discipline to study because there's many options, but not all options are made equal. So this just gives you an idea of what your mechanics are dealing with today. They've got gasoline, they've got natural gas vehicles, they've got propane, they've got hydrogen, electric, plug-in hybrid, and they've got hybrid, and they got your traditional diesel. So it's a big unknown world out there, but there is a clear leader coming through, which is electric, and we'll talk about that a bit more today. Next slide. So what is an electric vehicle? So let's just take a step back. A lot of times people are like, what is an electric vehicle to me, Naeem? They're like, there's that question. So it's a vehicle that's derived of a battery, a traction motor, a battery management system with a zero tailpipe emission. So sometimes they have DC to DC converters, AC to DC converters, and a few other bells and whistles. And on the right, you can actually see sort of the underlying layer of what an electric vehicle is. And on the top, you can see the Ford F-150 Lightning. And I really love showing this picture from my North American background, that it's the number one selling vehicle. So they sell over 1 million units per year of the Ford F-150, and they say its conversion to electric will be a game changer for North America. There's bi-directional charging that can come. You can charge the vehicle with it, and then you can charge bi-directionally back. So next slide. So let's talk about the EV market today. So one of the great sources of this space, if you want to do more research, is Bloomberg's NEF, which is the Electric Vehicle Outlook. So this is the 2022 outlook. As you can see, vans and trucks today represent 1% of the EV share. Passenger cars represent 9% in that segment, buses 44%, and 2 and 3 wheelers 42%. And at the bottom, you can see the quantity of the EV. So in vans and trucks, 600,000. In passenger cars, 16 million. Buses, 685,000. And 274 million in the 2 and 3 wheeler space. So you can see the markets that traditionally vans and trucks and passenger cars, there's a huge growth still. Bloomberg predicts between today and 2050 a $53 trillion market with a global energy demand by 2050 that will be 27% higher than today's energy demand as these vehicles come online. Next slide. So where is this transition actually happening? So you can see here China has been one of the predominant forces for many years in this space. Europe has now really started stepping up its game in terms of purchasing, and you can see that green bar of Europe growing much faster. And then the US is now, so, I think the US 2024, 2025 are years you're going to see big growth. We've seen a lot of sales in the US market, and we see continuous interest. But unfortunately, there are growing pains with this technology. And one of those growing pains is charge points, having access to reliable charge points. I was reading a study done about last month that 60% of the DC fast charging network in the US is down or unreliable for charging purposes. And that's a huge issue when you only have a few thousand chargers out there. Next slide. So when you segregate between truly electric vehicles versus plug-in hybrids, you can see that the industry is aggregating to pure play battery electric, so that's a good sign. But plug-in hybrids do give you best of both worlds in terms of range and flexibility. So, but they do come with their challenges around. They still have a tailpipe emission, and they, it means maintaining two separate propulsion systems. Next slide. So when it comes to the EV charger market trends, this one's interesting. Again, you can see China is a dominant force, followed by Europe, then the US and Japan. But you can see in the last 5 to 7 years, we've really started focusing on EV charge points and understanding where they should be, how they should be rolled out. When I was in Berlin last week chairing the conference around EV charging, one of the big issues with chargers is the fact that you have multiple apps, different brands operating different charger networks that are then requiring you to download their app. So payment processes are horrible for the user experience. And then the other thing that we are seeing is roaming agreements, where one charger operator's client can roam on another's network. And I think that's going to be really critical. I think we have to actually take it a step farther and legislate that requirement, that if you are building a public charging network, you must allow for roaming, because that's going to be critical to give the density of the charging network to the consumer as they start adopting more of these vehicles. So next slide. So to bring it all together, the drivers for transport decarbonization, the first pillar is government and policy. We're seeing carbon reduction commitments. We're seeing policy phasing out ICE vehicles. We're seeing grants and incentives. We're seeing emissions accounting. So what does that mean? So you've got a carrot and you've got a stick. Depending on which jurisdiction you are in the world, you can actually get a subsidy of maybe $5,000 all the way up to $40,000, depends on the class and application of vehicle, when you're buying your electric vehicle. That's the grants and incentive sides. But at the same time, you're hearing policy legislation saying by 2035 or 2040, all internal combustion engine vehicle sales will be stopped. So you're seeing the carrot and stick, as we say. So society and governance. So as employees of multinational companies, and all companies are really asking themselves, what is the sustainability footprint that this company is leaving, and how does it work towards that? So you're seeing that driver to create more sustainable approaches to do business. You're seeing customer preferences. Build back better after COVID is deriving that information that, let's build a better community together that, respects social and environmental impacts. Sustainable and ethical supply chains. Cobalt is a critical ingredient in many battery chemistries, and it struggles with conflict minerals. So that is one element that you're seeing companies like Our Next Energy out of Novi, Michigan, trying to readdress the battery chemistry by removing that and nickel. So in terms of environment and climate change, you're seeing the events. You're seeing like at COP28, COP27, you've seen it at COP26, you've seen it at Davos, this sort of collaboration to come together and look at ways to reduce our environmental impact and introduce cap and trade programs. On the technology and innovation side, battery chemistry, vehicle engineering, fuel cell design, all these items, you're seeing massive investments in how to bring forward the next generation. I tell people the solution for the world is still sitting on someone's lab desk. It's not been fully commercialized, folks. The end technology that's going to win this war and bring us the zero emission mobility that we all seek is still being refined. In Berlin, I saw companies like Green Mile, Electron, companies that are doing inductive charging, trying to improve the power transfer rate. So there's a lot of work still being done and ideas still being built out. And the big thing that they're all working towards around is range anxiety, right? As an average consumer, people want the flexibility and the freedom that a private car gives them, that they can travel anywhere, anytime, and there's a big fueling infrastructure network. So that is something that we need to replicate in this tech transition. The economics and total cost, there's a declining cost of EVs with scaled manufacturing. As I mentioned earlier, there's incentives to reduce the TCO, and they're predicting by 2025 that we will achieve parity in terms of electric vehicle capital cost versus ICE vehicles. So depending on the market, you will start seeing that sort of parity, and that will further increase the uptake and interest in the technology with the average consumer. But again, we need to focus on the infrastructure cost and make sure that we build a sophisticated charge point network that will give us the density that we need for this transition. Next slide. So this wraps up my presentation. I'm open now for questions.
Thank you so much, Naeem. Really insightful information there that you've shared. I personally have lots of questions, but I think we'll turn to the audience just to see if there are any questions so far. And I think there are. I think we're already getting a few coming through. So Naeem, the first question we've got in from Andrew is, how likely is it that cobalt will run out?
Yeah, so that's a great question. I think every mineral that we're extracting has a finite quantity. So there is, I don't know the exact date of when cobalt will run out globally. The problem with cobalt is there's a high concentration of it in Congo, and the extraction methods do not meet UN sort of standards of a workplace. I've heard some horrible statistics that 2 children die a week extracting this mineral. So it is child labor. No concept of PPE safety, and unfortunately, that's one of the reasons why, I don't know if you remember, in the 2010s, Apple was caught with their iPhones having that cobalt in there. So there was a lot of work around ethical supply chains, and that derives the same issue we're seeing now with electric vehicles, which require a substantial amount of cobalt in their battery pack production.
Wonderful. Thanks, Naeem. Let me just check. I don't think we've any more questions coming in just yet. We do have a couple of minutes before we need to move on, just to keep us time boxed. But I will just invite any other questions for Naeem right now. I think whilst we're waiting, Naeem, I do just have one very quick question for you, and that is just listening to the opening of your slides, particularly around the safety piece. That seems to be very prominent at the moment. Naeem, are you hearing more and more about safety becoming the one of the most important factors in the evolution of EV charging?
Oh yes, I think there is an entire retraining. There is a very big thought leader that I followed, that I was reading his post about a few months back, where he was saying that there's never been this type of transition in this pace, because if you don't invest in training, education, you're going to expose people to systems that they're not used to. It's like, I don't know if you remember this, but when the microwave first came out, I remember watching and hearing about these YouTube, they've got these little history clips. People were putting their children in the microwave to dry them because they just didn't know. And this is some of the risks that we have now with the EV transition, where people just don't know that, hey, look, I've used a garden hose. It looks similar to a charging cable. I can drive over it all day and night, right? They just don't have that understanding that you're actually dealing with a system that's taking high voltage currents through. And if that rubber around the copper is damaged in any shape or form, you're exposing it to a spark issue on arc. So,
Yeah.
But I think that is one of the realities. And just as you're mentioning about the safety and training, am I seeing that? So if you type in electric bus fires, I think about it was last year around June or July, it started globally. Like literally, there was a bus fire in China, then there was a bus fire in Berlin, then there was in downtown Paris, then there was one in Chicago, and literally everyone turned around and said, "Are we putting both feet in a little quickly on this technology?" So we really had to have that conversation and take a step back and look at thermal management risk and say, okay, look, we need to understand fire suppression. And one of the things people don't talk about is first responder training. I always say when you're bringing in technology into a neighborhood, invite your first responders, invite your firefighters, invite your ambulance folks, and let them know that, look, this is how you actually master disconnect the vehicle. And there's training around that. So it's really important to spend that time. I know sometimes we all get caught up in the the sexiness of the vehicles themselves and the how nice the lights look, but those first principles are really important.
Yeah, yeah, I agree. There's just a couple of questions come in. Matt's sort of asked a question on the back of this conversation we're having. It's quite interesting about he was surprised by the projected increase in fires, and his question is around whether there is the scope for battery management systems to detect electricity arriving through these damaged cables and shutting them down. I think the question is, are these fires preventable? I don't know if you've got a view on that, Naeem.
Yeah, so there's two types of fires. So there's fires related to the charging infrastructure, and then there's fires related to the battery of the vehicle themselves. So there's two separate things. So the first one, I'll tackle the charging cables. Yes, that's why I love doing my safety moment. It's just simple education. Guys, put it away, check it before you use it. Simple things like that. The second, around the vehicles, you're seeing as maintenance staff are starting to work on them, they fully don't understand. So they might be energizing components that they're not supposed to. So there's a lot of educational risk. So, the root cause of many of these global fires are not the same. So some of them were charger based, where the chargers just went off. The others, it was more focused on the battery management systems. And inside battery packs, there are thermal management systems. There's dispensers that shoot out foams and other stuff to deal with the fire. But like, if I had the time, I would show you this Paris video, but everyone Google Paris electric bus fire and you tell me what you think. It's like someone walking around with a flamethrower in Paris that's shooting out 50-foot flames. Like, it is a severe fire. And I'm still waiting for the report of what the root cause is, but all those buses have been grounded for investigation. So that's one of the points.
Yeah, no, I mean it's terrifying, but it's so important that companies and organisations are looking at this as a priority one as we move forward. I knew that this session would spark some innovation questions, but Dinesh has asked around, is there any possibility to produce a vehicle without a battery? I think he's listening to what you were saying about cobalt and the mining of that material and the damage that does. Have you heard anything on that or on innovation in that way, Naeem?
Yeah, so there's two technologies. So hydrogen fuel cell vehicles use a very small battery, and then they're using the hydrogen fuel cell to effectively power the vehicle. So that's the other electric vehicle that we rarely talk about. The other is supercapacitors can be used. In Bulgaria, I did an electric bus project where we were using supercapacitors that could move large swathes of power between the vehicle and the grid. So that's another option. Again, you can look at companies that are innovating, like Our Next Energy. They're cobalt and nickel free, so they're trying to extract the conflict-based minerals out to reduce their footprint, but they're still reliant on lithium. I've heard of salt-based batteries and sand-based batteries that are supposed to be pretty effective. So I think, again, like I have said, like the solution that we're looking for is not fully baked yet. So I think we will see more technology advancing in that space.
Yeah, no, absolutely. Naeem, there are questions coming in thick and fast, but in the interest of time, what we will do, we will take the questions that have been asked. We will try and come back to people after the call to make sure that we answer as much as possible. But Naeem, thank you so much for spending some time sharing that knowledge and taking those questions. Thank you very much. So with that, I'd like to switch gears, and I'd like to hand over to Marc Palmer, who I talked about in the introduction. Hopefully, Marc was having a bit of technical trouble, but should be with us now. He is.
Hello, yeah, I'm here. Good morning. Hi, everybody.
Brilliant. Marc, I'll hand over to you. I just want to check whether we've got your slides or whether you are going to present.
I am in charge,
Wow,
full charge.
okay.
Although, obviously, that means if I go on too long, then just pull the plug. So.
Yeah, no pressure. Well, we'll hand over. Thanks for joining us, Marc. We'll hand the mic
no
to you.
worries. Thanks. Good morning, everyone. Hi, nice to meet you all, and thank you very much for having me here. I'm going to share some slides with you in a second and answer some of the questions. Two things. First of all, my name's Marc. I work for a business which is UK based only, called OkdoTrade. OkdoTrade is a huge marketplace for people to do their research in car buying. So the stuff I'm going to present to you is pretty much insights around consumers, what the projection looks like, what the glide path looks like towards electric car adoption. It's UK based, but the insights are pretty typical of any established car market. And and if you're in a different place in the world, then there'll be a provider somewhere, I'm sure, that's got the similar sort of insights to what I'm going to share with you. So I'm going to talk about consumers and the glide path towards some milestones that have been set in the UK, and what is in the way of us achieving the kind of the penetration of electric cars that we need to achieve. And I'm going to focus on cars, by the way. I'm not going to focus on commercial vehicles or bikes or anything like that. And then some kind of solutions. And there are only a couple of big things for us to overcome. They are huge, though, and they are typical of any market that is on its path to EV adoption. So I am gonna share a screen. Let's see if this works. I mean, it's hard enough for me to join this this webinar, but let's see if I can make this work. I'm hoping everyone can see this here. Okay, it says it's sharing. 2023 is a pivotal year, and I'm going to explain to you why that is in just a second. This is a projection of the share of new car sales in the UK that electric cars will take over the next 10 years or so. You can see it's a pretty aggressive ramp up. We were at less than 1% 5 years ago, and in 2023 we think that's going to be nearly 1 in 4 new car sales by the end of the decade. So 2030, the UK government has banned the sale of new petrol and diesel cars. There will be some hybrids left over. They haven't quite quantified how many or what kind of hybrid is allowed to be sold after 2030, but basically what we're talking about is that 9 in 10 new cars will be sold will be electric by 2030. So that's the kind of path we're on. Now that's just new. What is really important for everybody to consider, so if you're a charge point operator or someone that builds hardware for charge points or software or payment systems or components or anything like that, all of that stuff on the previous slide is relevant, of course. But what it also means is that each of those new cars that's registered in 2023, 24, 25, 26 becomes a used car. So as the new car thing grows, those cars flow back into the market as used cars. And in the UK, the balance of cars in the market every year transactions, we sell about 2 million new cars and 7 to 8 million used cars. So used is huge. There are in the United Kingdom 32 to 33 million cars on the roads. And we estimate that by the end of the decade, nearly a quarter of them will be electric. So that's the kind of scale. We're talking about 8 million cars by the end of the decade. And at the moment, we've only just tipped over 1 million. That's the acceleration. And it was interesting to hear just back there, the Naomi talking about how fast this transition is going to be. This isn't like a new type of car that's impacting the car industry. This is completely different. This is a once in an industry change that we need to make, and it's happening in the next 10 years, which is much quicker than anything that's been happening in the car industry before. Loads of implications for that. So how have we been doing? In 2022, what we saw on our platform, just to quantify the size of AutoTrader, we get 10 million unique users every single month. We see about 4 times more searches for cars on our platform than you do on Google. It is the place that people come to look at cars. About 75% of all minutes spent researching a car purchase is spent on AutoTrader. So we've got tons and tons of data to take us to these conclusions. And as I say, as you can see there, last year we have new cars on our platform. 1 in 4 views of new cars was for an electric. Great big ramp up over 2020. That's brilliant. And at a market level, 77% increase in public charge points versus a few years ago. And there's much more choice for consumers, more than 70 cars to choose from. So that's quite good news. But let's come on to some reality checks and some less good news. There are really barriers to consumer adoption of electric cars, and I saw in the chat a minute ago one of you was asking about what are the barriers. There are kind of two. One of them is infrastructure and one of them is cost, and this is consistent with every established market. So we're just showing you here from a survey that we run pretty regularly. This is data from September last year, 6 months old, a sample of 2,000 people. And these are always the barriers to electric car adoption. The reservations are lack of infrastructure for charging, or the cost of those cars, or some other things around cost, as you can see in those dark blue bars. Number 1, lack of infrastructure. Number 2 is upfront expense. Number 3 is my home parking situation, which of course means I need to use public charging. And number 4 is that running costs of electric cars are unclear. In a product sense, people are generally quite cool about what these cars will do. Some people just reject them because they won't do the journey they need to do, or because they don't quite understand what an electric car is. Some people like petrol cars, whatever, but that is a minority now. We are talking, most people can kind of see that electric cars will probably be okay, apart from charging and apart from cost. And those are the things I'm going to focus on, or certainly charging now. When we look a little bit more closely at charging, the barriers to adoption are kind of falling, those two things there. So I called them out as being the two biggest barriers, but they're actually declining in people's minds. So you can see there in 2021, half of the people we asked told us that the lack of public infrastructure for charging was a big problem for them. That's dropped to 39% at the end of last year, and then upfront expenses dropped slightly also. So that's quite positive. The trajectory is quite positive. However, what we are finding, I told you that views of new electric cars was almost a quarter of all new car views. That has now fallen to 1 in 10. It's dropped by half year on year, and we're really concerned about the lack of interest, or the decline in interest in electric cars that we're seeing. And it's been a rapid drop off. We saw really high spikes last spring. You can see in the chart on the left there, 2 big spikes, one in February and one in June. If you're familiar with, well, first of all, the one in February happened in pretty much the week of the Russian invasion of Ukraine. People suddenly worried about fuel, about energy, about rising prices, started to look at electric cars as an alternative. And then the other spike that you can see on the chart there, the high point, is in June, July. In the UK, the price of a litre of fuel was approaching £2. Again, the cost of petrol is a thing that spikes interest in electric cars. As that price of fuel has stabilised, you can see the interest in EVs has dropped over time. We've then had in the UK some interesting developments with our household finances and our mini budget back in September. People's income, or people's disposable income, is squeezed, and therefore the cost of an electric car makes less sense for many people, and consequently interest has been dropping. So the two big things, cost and kind of charging and infrastructure, really volatile in terms of interest. One of the big reasons for that is because interest that we do see is driven by wealthy people. This slide shows us the demographic profile of people that are driving electric car interest, or the most interested in electric cars. That's the blue section on the bottom, and then on the top is your average car buyer, the Auto Trader audience. And you can see that there's a huge over index on people with higher household income, who are slightly older, slightly wealthier, and in the social grades. So one on the right hand side is really interesting. We have the social grades A and B, massive mix of people in those two most wealthy social grades. So when we kind of look at the general car buying audience, that's in the red. That's what the UK population is looking like, and in the blue there, miles wealthier, and the household income's higher, and so on and so forth. So interest being driven by the wealthy. There is at the moment no mainstream growth and not a lot of mainstream demand for electric cars, which, when we think about charging and public charging infrastructure, is a big problem. What are the barriers to switching to electric cars by age cohorts? So we know that wealthy people are interested, and we know that there's a lot of people rejecting electric cars. What does it look like by kind of age cohort? And what I've done on this chart here is split the research across the kind of three big barriers, and just to kind of give you a sense of how much pain or how big, how important are those barriers to different types of people. And you can see actually that older drivers just tick more boxes, 55 to 64, 65 to 74. They feel that lack of infrastructure is harder for them than the people over to the left. You know, the young ones, upfront expense is worse. The cars cost the same for everybody, right? But those people feel that that's more of a barrier, and the running costs is pretty consistent across the piece. Different reasons within that. Younger drivers will have more insurance to pay on any type of car. Older drivers less so. But even though they've got the same access to infrastructure, and even though the cars cost the same, whether you're 25 or 65, older drivers are telling us that those barriers are more important. And when we dig into charging, we've split this out by where the kind of location, the locale that people live, the concerns that they've got, and you can see across the bottom whether people live in the centre of a large city, the suburbs of a large city, a smaller town, or a village or rural area. And this is, I would say, this is UK specific, really different infrastructure considerations for places like the US and Canada, of course, where the geographical differences and car usage is very different. But key thing here, interestingly, people in cities don't tick as many boxes as people who live in small towns or village rural areas. And what I do think is really interesting is stuff like not enough on motorways, not enough at each station. Like, we all use the same motorways, whether I live in a large city or a smaller town. I have access to the same motorway network, and it is the case that 32% of people in the city think that there aren't enough motorways, but 46% of people in a smaller town think that there aren't enough motorways. So you can see that perception, and I'm going to come to this, of course, as the thing that we need to try to resolve. Perception is critical in making sure that more people are considering electric cars. Our summary of the data at the moment is that progress that we've been making is at risk. Anyone familiar with the sales figures that are published in this country will kind of be going, well, look, electric car interest is record last year, 17%, and January was pretty good as well, and December was really good. And there are reasons for that. Essentially, cars that are being registered, new cars that are being registered now in the UK were ordered last summer when that chart I showed you on interest was at its peak. Supply chain issues have meant that you've got to wait a really long time for a new car. So the people taking delivery of a new car now, Jan, Feb, March 2023, they went to a dealership back in April, May, June 2022. And now we've seen interest really decline. Our concern is that progress is at risk as we go into to the balance of this year. So I'm just going to give you a couple of ideas on things that we need to do to refocus and re-energize. And anyone who works around this space or wants to tell consumers about electric cars or stimulate interest for whatever reason, whether you're a manufacturer or you work in infrastructure or whatever, or policymaker or local authority, one of the key things is around information simplification. We've got tons of research and vox pops and studies and qual groups and all sorts of things where people are telling us it's really difficult to buy a car, but it's really, really difficult to buy an electric car. And the simplification of all the stuff they need to know in that choice and in that process is really important. So three kind of things there. Simplifying the information that I need to choose a car. That's kind of specifically around how far does it go on a charge? How long will it take me to charge that? If I charge it for half an hour, how long will it go? And if I charge it overnight, how far will it go? Given that charging is the biggest issue for people, that's kind of number one problem. I'm going to come to infrastructure in just a second. Afford is a major issue, as we've seen earlier on, and it's an issue for both new and used car considerers. At the moment, we're seeing a 38% premium on electric cars versus an ICE equivalent. 38%. That, for many people, that just does not stack up. Even when you take into account the fuel savings, you obviously don't pay for fuel on the EV, but you don't save enough unless you drive quite far. And it's very, very difficult to A, understand what those running costs are, but B, make them work. So there's still an affordability challenge, which I'm not going to get into here, because I just want to talk about that last one on charging. And there are a few things around public infrastructure, which in all of our research, and this will be the case in every country, having lots of charge points is okay. It might not be the answer. Enough is the thing we need. The Society of Motor Manufacturers and Traders in the UK has forecast that we need about 300,000 charge points to meet the targets by the end of the decade. That might be right. I don't know. It depends how people plan to use and charge their car. At the moment, 80% of electric car drivers in the UK charge their car domestically. They're charging at home. They're the people that can afford it and have got driveways to charge it. We're going to have to get beyond that and make sure that there's an infrastructure provision for everybody in any kind of way they want to use them. And I don't think we yet know enough about how people plan to use and to drive electric cars. So number one, provision, having loads of them isn't necessarily the right thing. And even within that, are they ultra rapid? Are they rapid? Are they fast? Who knows? And that is going to change all the time. And it's really difficult for consumers to figure out what ultra rapid means versus rapid, which means versus fast. And this is that part around time and distance. How long will it take me to charge it? And then therefore, how far will I be able to drive are the things that people have told us they want to know. The second thing is reliability. And again, previous speakers have talked about that. Infrastructure reliability is just not where it needs to be in any country. And the regulation of that is not necessarily helping at the moment, or lack of regulation at the moment. Payment systems are not helping. And there are emerging problems that we're hearing from consumers in different consumer groups. For example, we're hearing from women. Women are miles less likely to consider an electric car than men in the UK. We've dug into that a lot deeper. They're not as interested in cars in many cases as men, so they can be less bothered to do the research. I completely get that because it's really complicated and the car industry is really masculine. That's putting women off. The second thing is we're hearing increasingly that women are a little bit worried about charging alone. Are charge points in safe and well-lit areas? We've got elderly or disabled drivers who are finding it difficult to charge because the charging bays are too narrow or the cables are too heavy. So there's loads of different need states which haven't been considered. When we only think about charging, not about cars and affordability, just charging, that needs to be taken into account. And as I said, we don't actually have that long to do it. So simplification of information is important. The last thing I'm going to leave you with as an idea is if you are a charge point operator or a local authority or an energy provider, and you're wondering where to build infrastructure, my plea to you is don't build it where cars are being registered. A couple of reasons. The car is already registered. That's number one. People have already decided that they're going to drive an electric car. They're probably charging it at home. They won't necessarily need public charging infrastructure. It might already be done. The second thing is just because a car is registered to a house on a street doesn't mean that everyone else on that street is going to buy one in the same way and at the same pace. So I would ask you, if you are considering where to build those things, to think about where is there emerging demand for electric cars and where is there not charging infrastructure. So where are people looking for cars and not necessarily buying them? The idea would be that they're doing that because they haven't been able to find infrastructure to meet their needs. And if we put charge points in there, would that meet that need and therefore flip those people to buy that car? The last thing anyone wants to do is to build charge point infrastructure in a place where it's not going to be utilized. That is a waste of either public or private money. So for suppliers, our sense is that sourcing data on demand rather than registrations should be used to inform targeted infrastructure investment and make the use of that money much more efficient. And that is my final thing. If we make it easier and easier for consumers, we'll see more of them flip towards electric and get us towards those 2030 targets. And I can't see any of you, so I'm going to stop sharing and return to the call.
There we go. Brilliant, Marc. Fascinating data points. I think I'm already seeing in the chat that everybody wants to get a copy of what you've just shared because it is just incredible data. Thank you. Thank you for that. We do have some questions as well, Marc, if you're happy just to have a look through.
Yeah, of course.
I'll pick a few out. I think this is a really great one from Steve. He was first in before you'd even really started your session. That was around how does the rate of shift from the internal combustion engine to EV compare to the late 80s when we moved from leaded fuel to unleaded? I thought that was quite a good question to think about.
It is a good question. I don't know, actually. We haven't modelled it. I guess there'll be a couple of questions for me on that. The implications of the change from ICE to EV is what's important. So here's the thing, right? If I'm going to talk really simply because I don't maybe know enough about it. But if I was BP, or there are of course other petrol providers, I had a forecourt infrastructure within the UK, and everybody who drives does the same thing. They put the gun into the back of the car, and it's leaded fuel, or it's unleaded fuel, or it's diesel, or it's whatever, and that's the case. That isn't the case anymore. So the implication, for instance, in terms of how people make the wheels move on their car, or what the response for that and the planning for that is from energy providers or for fuel providers, is completely different. I also think that means that the unraveling of motoring infrastructure in the UK, parts of it anyway, has to happen much quicker and in a very different way to what it was before. So I get the question. I don't know whether it's faster or not, I'm afraid, but I do think the implications are greater for this change than they were for leaded to unleaded. But I'm not an engineer, so Steve might, if I think of it differently.
No, I think that's great. I'll pick a couple more just in the interest of time. I'm going to pick one from Sarah actually, because I think she supports some of the things that you were saying. She's really keen on an electric car, but there's nothing wrong with her current car, and she's not clear on the benefits of cost saving, versus the worry of charging points when she's got the kids and other things to worry about. I'm bringing that up because I think, Mark, that kind of supports some of the things that you said around some of those kind of things that are impacting what we're seeing today.
Yeah, that's a great one, and it's really common for many people. So what we're not very good at, and the Auto Trader is exactly the same, by the way, it's something that we're working on, is making it very clear to people that if you drive 6,000, 8,000, 10,000, 12,000 miles a year, and you run this car or this electric car, how much money will you save on running it? That for most people is all I want to know, because if the car costs me £100 a month more on a finance agreement or a lease or whatever, the electric car, then I need to be saving at least that, don't I, to make it work for me. Working that out is really, really difficult. So you're right to ask that question. And I also think, just one last thing, if anyone on the call is responsible for making that information available to consumers or to people, normal people, let's try to do it in a way that is super easy for them to understand. Because actually, a lot of the stuff we're hearing, especially from female considerers or rejectors of electric cars, is that their go-to, men are kind of got the brochure stuff, the numbers. Females are kind of going, well, what if there's an emergency? What if I needed to do this thing? I don't want to wait 45 minutes to charge my electric car when it takes 2 minutes to put petrol in. What if I've got kids and they need to do X, Y, Z? What if I need to take my so-and-so to this place? All of those considerations are real, emotional and very, very real barriers to rejection or to adoption. And I think if we don't overcome them and understand those, then we will struggle.
Yeah, absolutely. Mark, there's so many questions coming. We're not going to have time to cover them all live. But again, I'll just say to everybody on the call, we will try and get around those questions and make sure that we add to the threads so that we can come back to you. But Mark, I'll just say a huge thank you for that, and really appreciate you being with us today.
No problem. Thank you very much, everybody. Have a good day.
Brilliant. So just in the final segment of our session today, in the last 10 minutes, we've heard about the trends, the adoption, the infrastructure. And what I'd like to do now is just talk about the EV design innovation that we as OKdo are seeing, and that is incredibly relevant to what Mark and Naeem have shared with us. And just before I start the slides, I just want to share with you, before this session, I was lucky enough to speak with 5 of our customers, all of them in Europe, around their design innovation challenges that they're facing today. And I just want to share, before I go into the slides, that there are some common themes that have come out already from our guests on this call. And that is, from an engineering perspective, our customers that are looking at developing EV charging solutions for the future are absolutely focused on safety, on compliance, particularly CE, FCC, ESD compliance, security, making sure that all vulnerabilities are removed, network interoperability, and the ability to scale with the introduction of new technology, such as cameras that are becoming more commonplace. From an operational perspective, our customers are really interested in robust supply, in global availability, in advanced technical support, and cost effectiveness, of course, as Marc and Naeem have already alluded to in a couple of data points that they've shared. So just coming on to a couple of points, just to round that out with regards to what we're doing as OKdo. We are very focused on single board computing, and we are using single board computers as an acceleration in the design journey for our customers. I do just want to pause because I can't see the slides at the moment. So Katie, if you are there, it would be good to get the slides up. That's brilliant. Oh, they were there. They've gone again. Sorry, we have done well for technical issues, but hopefully the slides will be back up. Yeah, there we go. So just leading on from what I said, why are single board computers the right choice? Well, first of all, just to make sure everybody's aware what single board computers actually are, they are small computers that have all of the processing power and I/O interoperability built in, and that can be designed into end applications. They often follow a form of a single board computer supported by a compute module, which may have a reduced I/O, such as USBs, HDMIs, etc. And then obviously there is the silicon, the microprocessors that they are based on. And that we're seeing is a real innovation wave in the EV market. And so why are our companies, why are design companies that are either working for private or public organizations coming to OKdo and other companies to look at SBC solutions? The first thing is time to market. By having something that has got a lot of the design work already done, in most instances already pre-certified, so having those important CE ratings means that those companies can accelerate their time to market. They also offer engineering efficiencies. So SBVs provide a tested hardware and in some cases software that can be integrated directly into that end application. And actually what we see as an end application in most instances when it comes to EV charging is an SBC board, some type of adapter that then communicates with a display inside a rugged enclosure, depending on where those units are being used. Also, SBCs offer supply chain optimization. Often when you buy a single board computer, a lot of the cost optimization work has been done, and also the robust supply chain is in place to support those design activities, which gives customers a huge amount of confidence. And that then links to performance versus cost. That cost performance equation that engineers and design companies are always looking for is met in the form of that single board computer and the pre-work that's already been done. And I talked about when I spoke to customers around what's important to them, they talked about scalability and ecosystem. And that really means being able to scale an application through hats or shields or carrier boards that are actually designed to work with the SBCs and scale that into more advanced technologies, depending on where EV charging goes over the next 2 to 3 years. Next slide. So how can SBCs be used in EV applications? Well, they're being used today. We are seeing a huge growth in this area, particularly around public companies looking at infrastructure development and also private companies that are looking to innovate on the back of some of the challenges that we're seeing in the market today. Some of the big things that SBCs are used for is, number one, to ensure security of those EV chargers. EV chargers can be in remote locations. They can have incredible vulnerabilities. You open up the charging station and you could have access to data and information that is highly sensitive and that you wouldn't want to be out of that enclosed environment. Utilizing an SBC, you can use secure boot features that allow that to be, those vulnerabilities to be kind of closed out as much as possible. They're also used for energy management, and energy management can be around the charging station and the power grid, as well as the load management on the networks as well. And the computational elements of the SBCs allow for that kind of management. They can also be managed remotely. So the connectivity that is on board these devices means that you can manage that data from a central location with a software offer. And also control and monitoring is a big part of how SBCs are used in the EV applications. And I've talked about that already, but really, listening to what Naeem and Marc shared with us, being able to manage the power efficiency that's being deployed inside those charging units and being able to manage those processes safely is a growing concern and a growing priority for us as OKdo, but as our customers as we move forward. So just to recap, I don't want to repeat myself, but I think that there are real opportunities that we're seeing to work with public organizations, private organizations, to really make sure that we are leveraging the SBCs that we have and the broad range of partners that we work with. And we work with big semiconductor companies such as NXP and Infineon, Rockchip. They all have a role to play in the single board computer technologies that we're making available. And what's really good is that we can work with our customers to make sure that we find the right solution for power management, the right solution for the reliability issues, the security that I've talked about. We also can work with our customers on the space. Single board computers are very compact. Their form factors are often the size of a credit card. So when it comes to adding smart functionality to already important power control, DC charging, etc., then we can do that without making huge differences to the mechanical designs of those EV chargers. And then finally, just the convenience aspect, the fact that they can buy something off the shelf that can be fully integrated and can be supported with detailed technical support up until the deployment of those devices into the field. So I think, for me, single board computing and EV charging has got a great future. I think together we will solve a lot of the engineering challenges and safety challenges that are in the market today. And I just want to end with just one case study. I talked about the customers that we spoke to before this session. And one of the customers just allowed us really just to share a little bit about how we've been helping them on their journey. The customer is 6 Watts. They are a customer that we've been working with for a little while now. Adam Heavens is the guy that we work with, and he brought to us a challenge in the fact that he'd already designed in an SBC into an EV charging solution project that they've been working on. But unfortunately, like many companies over the last few years, the electronic supply chain shortages and other issues meant that there was some stalling going on within 6 Watt with regards to them being able to deploy the solution that they've developed. So we worked with them, with our sales and technical team. We looked at what their business needs were. We looked at specifically things around reliability, compliance, and what they really needed to offer their end application. And we actually came up with a solution utilizing our ROC range of SBCs and compute modules. In this instance, we used a compute module 3 as a replacement for what 6 Watt had been using previously. And we're now working with 6 Watts to make sure that we can now ensure a cost-effective solution that meets their technical requirements, but actually has a robust supply chain to ensure that the deployments that they have through 2023 and beyond can be met. And I think, this is a really great example, particularly around the supply chain operational issues that customers are looking for, where we've been able to meet technical needs, we've been able to provide a solution, and now obviously working together to deploy that. And I think 6watt, along with many other customers, you're going to hear a lot more from OKdo this year of the work that we're doing. And actually, what I'm probably most excited about after today's session is being able to showcase how some of the innovation that we are working on behind the scenes is going to answer some of those really prominent publicly exposed challenges within the EV charging infrastructure build as we go forward. So I'm going to pause there. We are a little bit over time, but I will just open up for any questions that we have at this stage. So I'm looking in the chat. I think that we are, unless I'm missing something, sorry. I think we're good. There doesn't seem to be any questions in the chat right now. So just in the interest of time, because we are right on the hour, if there are any questions, or if anybody on this call wants to talk to the team at OKdo or get access to anything that we've talked about today, please get in touch with us. The details are on the pages where the registration was. I want to thank Marc and Naeem and the team at OKdo for the support today. Thank you for joining us, and we'll close the call there. Thank you very much.